Welcome to your last video on function operations. The first video we did was just about domain and finding domain restrictions. The second video was on adding and subtracting functions. Third video was on multiplying functions. This one is on division. Sounds scary, but don't be scared because the division is actually probably the easiest because I'm not asking you to do a lot of dividing. You're going to write things as a fraction and then state the domain restrictions. So our learning targets are, I can divide functions, and again, I can state the domain of a function. Can you tell that it's pretty important to be able to state the domain of a function? Yeah, it is. Okay, let's get into it. So this example says to let f of x equal x squared minus 9 and g of x equal x plus 3. What is f divided by g and its domain? So if we want to find f divided by g, all I'm really going to ask you guys to do is write the f function x squared minus 9 over the g function x plus 3. That's as far as I'm going to ask you to go with it. So the division is pretty simple. X squared minus 9 over x plus 3. But then I want you to state the domain. So look at this solution or this operation we've done, and let's talk about red flags. Do we have any x's under radicals? No. Do we have any x's in denominators? Yes, here comes the red flag. So what is our restriction when we have a variable in the denominator? We have to say that this entire expression, x plus 3, is not allowed to equal 0. So x plus 3 is not allowed to give me a 0. Solve that by subtracting a 3 on both sides. And so x is not allowed to equal the number negative 3. So how do I state that domain? Well, the domain will include all numbers except negative 3. So that's going to include all the numbers from negative infinity up to negative 3, union with negative 3 up to positive infinity. So division, we're just going to write one function over the other and then take a look at the domain restrictions. In our second example, f of x is 3x squared minus 11x minus 4, and g of x is 3x plus 1. So we are going to write f divided by g of x is equal to the f function, 3x squared minus 11x minus 4, all divided by the g function, 3x plus 1. That's as far as I'm going to ask you to go with division, so this is sufficient for the answer. But I do want you to think about the domain. Do we have any x's under radicals? No. Do we have any x's in denominators? Yes, right here. So we have to say this entire expression is not allowed to equal 0. So we have our little red flag here. So 3x plus 1 is not allowed to equal a 0. Solve this by subtracting 1 on both sides. So 3x is not equal to negative 1. Divide by 3. And x then is not equal to negative 1/3. So x is not equal to negative 1/3. That means that our domain includes all numbers except negative 1/3. So it includes all the numbers starting at negative infinity, going up to negative 1/3, union with all the numbers from negative 1/3 up to positive infinity. And notice here that all my brackets are curved. These are curvy brackets because the negative 1/3 is not included in the domain. Okay, in this next example, we are looking at f of x is the square root of x plus 1 and g of x is equal to 2. We're supposed to find f divided by g and state the domain. So f divided by g of x, that's going to be the square root of x plus 1 over 2. That is fine for showing the division. Stating the domain. Let's talk about our red flags. Do we have an x in the denominator this time? We have a denominator, but do we have a variable in the denominator? No. So we don't have a red flag for that, but we do have an x under a radical here. So we're going to take this x plus 1, and we will say that x plus 1, it's under a radical. Is it allowed to be 0? Yeah, it is, because it's not in the denominator. So we just have to say it's greater than or equal to 0. X plus 1 can't be negative. If x plus 1 comes out to be a negative, then we've got a problem. So x plus 1 has to be greater than or equal to 0. Subtract a 1 on both sides. And x is then greater than or equal to negative 1. So my domain includes all numbers that are negative 1 or greater. So the domain includes all numbers that are negative 1 to infinity. And our last example says f of x is the square root of x plus 1 and g of x is equal to 2. We've got the same two functions, but we're flipping it upside down. It says, what is g divided by f of x? So g divided by f of x, we're going to put our g function on the top, divided by our f function, the square root of x plus 1. This is all we need for the division, but let's talk about that domain. This time, do I have an x in the denominator? Yes. Do I have an x under a radical in the denominator? Yes. This is what I like to call the double red flag situation. So this time, my quantity x plus 1, it's got to be greater than 0, but it cannot equal 0 because it's in the denominator. It cannot equal 0 because it's in the denominator. So x plus 1 is just going to be greater than 0. Subtract a 1 on both sides. I get that x is greater than negative 1. So my domain is going to include all the numbers that are greater than negative 1. What is that going to be? Well, the numbers bigger than negative 1. Start with negative 1 and go up to infinity. Negative 1 is not included. I'm going to use this curvy bracket because I did not have a line under that inequality symbol. So this is my domain. So I really hope that this series of lessons has helped you to learn something new while I've been away. Let's review our learning targets. I can divide functions, and I can state the domain of a function. We've done a video on adding and subtracting functions, multiplying functions, dividing functions, and then we've done a whole lot about domain. So I hope that this has not been a waste of your time, and I hope that you felt like you've learned something while I've been absent. And I should be able to see you in person, in class, tomorrow. So I know we're all excited about that. Good luck finishing your assignment. I will be taking a grade on the work that you've done while I'm gone. So get to work.